Hello everyone, and welcome back to the very first Indexer Office Hours of 2025. I'm wishing you all a happy new year. I hope you all had a wonderful break and are ready for what is going to be a fantastic 2025. I am very excited. For all who are new to Indexer Office Hours, this is the town square where graph ecosystem participants come together and discuss the most important and relevant topics for indexers. This is a conversation, as I always like to say, and we love participation. So please do get involved in today's conversation. We have a GRC20 conversation, and we'd love to hear your input and thoughts. And so, yeah, feel free to get involved in today's conversation via the text box, which many of you are already utilizing, or by unmuting your mic. And if you're having any challenges unmuting your mic, let me know, and I will try and get that sorted for you. As a reminder, this is a call that's going to be recorded and posted onto public channels like YouTube, so please bear that in mind. And with that, let's get into today's agenda. So this is episode 189, and as I like to do always is give a shout out to the latest GRT IQ episode, and that's 202. We're at episode 202, which is crazy. Yes, there's some errors with the links, unfortunately. Is Nick in the house? Nick is not here. Okay, I will message him separately. Yeah, because I had some troubles with the links there. But as Juan has posted, thank you, sir. It is a wrap up for the best bits for 2024. Nick is probably in his house, not ours. you know what I meant, Juan. That's funny. Yeah. So the links there are for the wrap up, the best bits of 2024. So highly recommend. Yeah, Nick isn't in your house. Juan, I thought he was in everyone's house. Yeah, so do check out the links there. Thank you for posting, Juan. And without further ado, I'm gonna send it over to Anna for our regularly scheduled Repo Watch section.
Thank you, Juan. Abel, sorry. Hello, everyone, and Happy New Year. I guess I'm more used to saying thank you, Juan. Okay, so Repo Watch. We have quite a few releases, so let's go straight into it. Starting with execution layer client, we have had a new release from Aragon. This is version 2.61.0. This release includes updates to implement the Pectra network fork specification, and all operators should review these changes for compliance and performance improvements. It's a yellow urgency indicator, which means it's not immediately critical. Next, we have a new release from Read. This is version 1.1.5. In this version, the legacy engine implementation is no longer the default, and support for it has been entirely dropped. This release also includes some performance improvements, some bug fixes, and breaking API changes. So you should check this release update out. Important to know here that due to the legacy support removal, you should update as soon as possible. Then we have a new release for Nethermind. This is version 1.30.3. Which requires all nodes on OP mainnet and base mainnet to upgrade to this version and OP node 110.2 by January 9th, 2025, which is in a couple of days, so this Thursday. And this is due to the Holocene hard fork. If you don't upgrade, then you will have issues with incorrect node functionality. So update as soon as possible. On Avalanche, we have version 1.12.1, which fixes p-chain mempool verification to prevent transaction exceeding chain capacity and to ensure network integrity. It also contains more configurable options for PebbleDB, plus other enhancements. This is not a critical update. Arbitrum Nitro, so version 3.3.1. fixes a tracing regression from 3.2.1 and enhances reliability for blockchain operations. This is a yellow urgency indicator, so it's an important fix for tracing regressions, but it's not necessarily something that you need to upgrade immediately. Moving on to consensus layer clients, here we have a new release from Teku. It's version 24.1, which includes bug fixes for gas checks, API responses, and lib P2P message size, ensuring better operational stability. Please note that the upcoming version, which is 25.1.0, will introduce a lot of breaking changes in the metric names. Again, yellow urgency indicator, so not immediately mandatory to upgrade. Then on the graph stack, we have had two new versions for indexer tap agent. So this is version 1.7.4, which includes bug fixes that enhance stability by adding receipts timeout configuration, shutting down the tap agent on database connection loss, and ensuring messages are listening. Message listening starts correctly after initialization. Again, yellow urgency indicator, not immediately critical. However, we are running this version on both testnet and mainnet without issue. And then the last version here, indexer service version 1.4.0, which adds a graph indexer header to subgraph query responses and improves request status metrics. It also contains other fixes for middleware routing errors and status code updates. So these updates enhance functionalities but do not impact critical operations. We are running this on both testnet and mainnet. We have encountered a bug to do with serving queries directly to indexer service with a free auth token when a subgraph is not allocated to. So you get a 500 internal server error. However, this shouldn't stop you from upgrading. It's just something we've noticed in the event anyone else notices it as well. And I know that I think it was Derek from Data Nexus who posted the bug. So thank you for sharing that, Derek. This is all I have. Over to you, Juan.
Thanks, Anna. Okay, getting into Protocol Watch, we have a couple things to cover. First of all, for forum governance, we have updates to GDR22 and GDR24, mainly, getting all of the information for the, arbitration council to take a decision on those two ones. I think GDR22, if I'm not mistaken, it has a lot of interesting technical discussions as to, how liable or not is an indexer to issues in the RPC layer and other stuff. So if you're interested in any of those technical discussions, I would recommend anyone to go through those two disputes. They're pretty interesting. I think it was again 22 was the most interesting one. So yeah. Then we have some updates from Yaniv on GRC20, mainly some answers to, I think, Tomas's questions. Again, the GRC20 discussion is pretty lengthy, so if you're interested in that, the link is in the agenda. So yeah, you go ahead and check it out. For forum research, we don't have any new updates. For the contracts repository, we have two open PRs have been updated, mainly Chore PR to add over-delegated tests to subgraph service, as well as a fix to the closed tail allocation function. Nothing major. For the network subgraphs, we don't have any new updates. And that's pretty much it for Protocol Watch. I don't know if Paka's around, so I'm going to be handing over to Abel now.
Yes, amazing. Thank you both for your sections there. We have the good fortune now of having Chris and Yaniv join us today to talk all about GRC20, which many of you may have seen in the tweet that was sent out before this. And so without further ado, I would like to both invite you to the virtual stage, if you will, to tell us more about GRC20.
Awesome. Thanks, Abel. Hey, everyone. Really great to be with you. Happy New Year. Really excited for the year ahead. It's going to be a big one. We've got many years worth of work that we're ready to release. And I think, this is finally going to be the year of Web3. I know a lot of you have been with us since the Mission Control testnet, right before we even launched the network. And, the mission at the Graph has always been to make Web3 real. We've been hard at work, and, I think we'll really be able to say that we did it this year. So I'd love to share and start a little bit at the beginning and then introduce everyone to GRC20 and make sure that y'all understand, what's the stuff that we're releasing, and what it means for the Graph, what it means for you as indexers. So a lot to cover. So I want to start with just a quick recap of this post that I published middle of last year, Knowledge Graphs are Web3. And I think it's always good to kind of start with a bit of context, which is, if you look at, what the Graph is mostly used for today, and as an industry where most of the traction is, it really is in DeFi, right? Most of the subgraphs we have, right, are kind of DeFi based. And, we're constantly, oscillating between, this kind of, existential questions about like, hey, is all of this decentralization technology only good for DeFi? DeFi is the only killer app, or, was the whole Web3 idea maybe not even real to, people really believing in Web3? It kind of oscillates. We really do believe in Web3, but we think, we need to understand exactly what this thing is supposed to be. And as the Graph, we really want to enable, this brand new platform. And so, Web3 is a new platform for decentralized applications, right? And I think, the core properties of this platform, right, is verifiability, openness, and composability, right? We believe that, we should be able to rebuild every type of application to be verifiable, open, and composable, and that we don't want these applications to live in silos. We don't want them to be controlled by corporations, right? That's why we're here. And yet, if we look around and we're like, hey, where are all the Web3 apps, right? Like, what are the apps that we're using every day that are on Web3? What apps are our friends and family, people who aren't even in the crypto industry using every day that's on Web3? And obviously, we haven't crossed that chasm yet. And so the claim of this blog post is that the thing that's been missing is composability, because we have pretty good versions of verifiability, openness, right? You can sign transactions with cryptographic signatures. We have these decentralized networks, right, like the Graph network, where everything is kind of open, and folks like yourselves can come in and provide services. But what we haven't really had is the composability. Right. And if you look at like subgraphs, for example, most of the consumers of subgraphs are actually like the developer that built, the underlying protocol. I think we see that there's a lot of these verticalized apps. So maybe I built a lending protocol, and then I built a lending subgraph, and then I built a lending application, and it's this kind of vertical thing. But it's not really this ultra composable thing. And most of the use cases are financial in nature. But really, we believe that these properties of verifiability, openness, and composability are really going to be useful for every kind of application, right? You can just think about any generalized information, and you want to have access to public knowledge and information. You want to be able to use it in your applications. You want to be able to contribute to it. And that's what we want to enable. And so we believe that knowledge graphs are really kind of the solution to this. And so, we published this blog post, and at the end, we talked about the semantic web, right, which is kind of the original vision by the original architects of the web to build this kind of global decentralized knowledge graph, right, to basically, like Tim Berners-Lee always wanted it to be a graph of data, right, or a web, he called it a web of data instead of a web of pages. And then on top of that global web of data, you could build any kinds of applications. And I think there's a few reasons why that didn't work the first time around. I listed 3 here, right? The first is basically the main standard that was created by the original architects of the web, right? RDF and Sparkle. We think there were some issues with it, which kind of hindered its adoption. The second was that you actually need pretty robust governance processes for standards, right? If you want to have different applications that are building on shared schemas, and sharing data, you need to have some ways for those different folks to coordinate, and we didn't really have good solutions for that. There's kind of governance. And then the third is kind of the incentives, right, for running the infrastructure and this stuff, right? The centralized platforms really outcompeted because they could monetize better, and then they could, invest that into better infrastructure and better user interfaces. So this is why I believe this vision of an open, decentralized web essentially, failed, and then things re-centralized. And I think we finally have the solutions. So this first problem, right, is basically about the standard for the knowledge graph data and for kind of querying that, and that's where GRC20 comes in. So we published this blog post, and we published a new standard for knowledge graphs called GRC20. And this blog post goes over some of the kind of use cases. I'll give you just a high level understanding, for basically like why a new standard, why not RDF. So I'll give you my 3. There's actually quite a lot of reasons, but my 3 biggest ones are first. If you actually look at the RDF standard, it is quite complex and academic, and to actually like implement the standard, right, for implementers, like there's a lot of like what I would call incidental complexity, and I think that kind of thing makes it so people don't want to use it, and that was one of the things we wanted to address. The second is that they don't support the property graph model, and so when we look at graphs, and I'll give some examples of graphs. You have nodes and you have edges, right? We call them entities and relations. And with the property graph model, the edges themselves can have properties on them, and that's super powerful to be able to describe facts about the connections between things. So it allows you to make more powerful graphs. So RDF does not support that, and that's an important feature that modern graph databases support. We think it's important to support that, so we have that in GRC20. There are there are other issues with RDF if you look into it. So I'm going to start just talking about the third I wanted to call out is how they represent IDs, and this is a big one. So the IDs for entities in RDF are basically resource locators, and usually what they do is they'll point to a server. They'll basically say, oh, you want information about this entity? Go to the server. That's where you can get the information about the entity. They'll give you back the data, and essentially that's kind of a mutable like server-specific way of getting the data, right? It's like the difference between like HTTP and IPFS, right? So in our case, we're not doing content addressing, but we do want this thing where like you're not going to a single server operator, right, who's basically the source of truth. Whatever they give you back is the answer, right? That's very much not a Web3 way of looking at things, right? So we want the IDs to be decoupled from any server operator, right? And so those are three of the biggest issues. If everyone's like, hey, why not just use RDF or something? And at the end of the day, I think the proof is in the pudding that RDF has had over 20 years. It's been mostly niche, but graphs themselves are huge, and they're I think more and more people are understanding the power of graphs. And especially in the age of AI, knowledge graphs and graph databases like Neo4j are becoming extremely popular because they're actually like the perfect tool to use for things like LLMs. Maybe Christoph will share a little bit about that. So for us, for the graph, like this was always the vision. And actually the first version of GraphNode, not a lot of people know this, but the first version of GraphNode was actually a triple store. So we knew that there was something to this idea, but we didn't have all the pieces at the beginning. And then, you know, DeFi started taking off. We started really optimizing for DeFi use cases. But now we believe is a good time to actually go back and finish building the pieces and really, you know, enabling Web3. So let me go a little bit through the components of GRC20 so you understand what this thing is. I know I came and I spoke to this group, you know, about a year ago, and you know I shared a bit about Geo, but now we have, you know, a standard for knowledge graphs that could be used across applications, right? So I think one of the things I'd love to kind of communicate is, you know, what's the distinction between, you know, Geo and the graph and different kinds of things. And so ultimately, you know, we think knowledge is an important first-class thing, and we'd love for everyone to really understand the distinction between information and knowledge. And we think the knowledge is something that needs to live natively on the graph. And so even though, you know, my team has been working on this stuff for many years, you know, the idea is, you know, Geo essentially is just one application, right? We want Geo to be this kind of generalized browser, this generalized application, but really we do want to, you know, empower developers to build any kind of application, right? That consumes knowledge from the knowledge graph and can contribute knowledge to the knowledge graph. And so, you know, GRC20, it's right, it's a standard that is very, you know, separate, and then Geo is just one application that allows you to interact with the global decentralized knowledge graph. So GRC20, the first class concepts here are entities and relations, right? So everything can be described as like an entity, right? Any person, place, thing, idea, concept can be represented as an entity, and then these entities have relations between them, right? So if you have like a content marketing course, right, maybe the course has many lessons, so each of the lessons are their own entities, and there's relations between the lessons and the course. Maybe there's different topics, so you know you have so what makes this a graph is you have kind of these nodes and these edges between them. The atomic unit of data in a knowledge graph in GRC20 is a triple, and a triple, right, it's an entity attribute value. And one thing that we do different, right, there's also, you know, there's apps like Obsidian, right, and these different things that are very kind of graphy and are very cool. But sometimes, you know, what these apps do is they allow you to define these kind of like local graphs. And what we're trying to do is we're trying to build a decentralized, like a global knowledge graph, right? Because all knowledge is interconnected, right? There really are not these artificial boundaries between things, right? You know, so somebody gave an example of, you know, maybe for substreams, you want to start out and you want to, you know, see information about a substreams module. But maybe as part of that, maybe you have a question about Rust. And, you know, Rust, is that related to substreams? I guess it's a more general software concept. Or maybe there's like a team, right? Maybe there's a team building on Ethereum or on Solana, and you're looking at this module and you want to learn about that team. Hey, is this a credible team, right? Who's part of it? How long have they been working on this? So there's always like, you know, information. You know, you could always want to, you know, take another step further because everything is kind of interconnected. And so we want to have this global knowledge graph. And so what we do is, so every entity has a globally unique ID. And this is quite powerful. So, you know, if I want to refer to the city of San Francisco, right, if every application uses a different ID to refer to the city of San Francisco, like how are we supposed to make sense of that? And especially because different words could mean different things in different contexts. And so having global unique IDs, so you know, okay, are we talking about the same thing or are we not? And hey, what are all all the different applications, what have they said about this particular thing, and then, that can allow you to aggregate things, and, that really gets to composability, right? This is kind of what we need to be able to do. But it's not just the entities that have the globally unique IDs, it's also the attributes. And so, anytime that we're talking about a birthday, for example, right, maybe this is the attribute ID for the birthday property. And so, we could be talking about Albert Einstein's birthday, but we could also be talking about the birthday of, maybe, for example, a pet, right? So here, Albert Einstein is a person, but, maybe a pet also has a birthday. Or so you can have properties that themselves, distinct from the entity, can exist. And so the attributes have globally unique IDs, and then you have a value, right? So this here is a triple, right? It's a single data point. And one of the principles with GRC20 is we want applications to be able to produce knowledge, right? And so you can think of knowledge as being a collection of triples and relations. And so you produce knowledge, like here's a bunch of facts about anything that I care about. I can describe these facts, and then I can publish them. And then that knowledge is interoperable. So any application can interpret and understand the knowledge that has been produced by other applications. And so we have these like native types. But then what we allow you to do is define these higher level types. So we talked a little bit about relations. So you can define types, and what we do, right, because, all of you're very familiar with like Postgres, right, which is like a relational database. And so you have, these tables, and the tables are kind of like types, and then, they're relational, so they have relations between them. But relational databases are very strict. And you have to know the structure up front, right? You have to know these are the columns, right, on the table. And if you want to modify the columns and stuff, right, you have to, it can be an involved migration process. And if someone tries to add data to the database, right, to the table that doesn't conform to the exact columns that are in that table, you're going to get an error, right? And so, if you're constantly dealing with these errors, I mean, that's within a single application, but then you imagine having interoperability between thousands of different apps. The data is never going to look exactly like, that one table that you have. And so you're constantly going to deal with these mismatches and trying to figure out how to like get that composability, right? That interoperability. And so so the way GRC20 approaches types is that it's a way of providing structure, right? So you could think of the difference between data and information being that information adds structure to data. And so, for example, maybe we're talking about a place, and a place has these properties. It has an address, it has maybe hours of operations, a phone number. So this is a structure to, we know that places may have these fields, right? But they don't have to, right? So it's kind of like a hint, but we don't enforce these structures. And then with GRC20, entities can have many types, right? So Golden Gate Park can be a place and a park. So park could define fields that are relevant to parks, right? Place can define fields that are relevant to places. Entities can have many types. And this gives us a really flexible way of adding structured information, but without limiting and without breaking composability, and making it so you can really have many different applications that are producing and consuming this stuff. And then we have relations, and I mentioned a little bit, about, for example, the strength of property graphs. So maybe, we have James and Anita, right? Maybe they're married, so there's a spousal relationship, but then there's additional properties on, right, this relation. So maybe we want to say that the wedding is an entity that's related to this relation. And so you could go, hey, who's James's spouse, and give, show me whatever they've published about their wedding, maybe where they got married, stuff like that. So it's super, super powerful. So this is just like a little overview. We have the full spec here. A few things that are maybe relevant to y'all is we use protobufs for the encoding. We specify how to encode the data, decode it, and how to define things like relations. The type system, all the stuff is defined here. We have an active forum post where there's discussion there. So if you have any feedback on the spec, please leave it there. And some things that are coming up. So we published this, and we did this as really the first step, because everything is dependent on the serialization. You know, we can't have any knowledge on the knowledge graph until, you know, this is really been frozen, and we really want this to be kind of an open standard. So we did this first. We're going to have an announcement coming up very, very soon where we go more into governance. So I just want to share a little bit about this. I want to make sure I have time to hand it over to Christophe, and also to leave room for Q&A. But the goal for the graph, right, and let me start with some kind of high-level goals, right? 2 top-level goals that I would really love to see us focus on as an ecosystem this year is more useful knowledge and information better organized, right? So, you know, people might have their own definitions for what they consider to be useful knowledge and information. And, you know, we really want Web3 to start to be usable, you know, across every industry, across every academic field, across every part of society. I've got a bunch of use cases that I'm very interested in, and maybe, you know, you have use cases that you're interested in. There's so many use cases for this stuff. 2 example use cases that I think could be interesting for grounding some thoughts around this stuff. One is news, right? So I think, you know, everybody feels the pain of, you know, it's hard to know what to trust. You know, when you're looking at news, you can't tell, okay, is this journalist biased? You know, is this fake news? All of this stuff. So anything that can help us structure, you know, and better understand what's happening in the world, you know, where it's so noisy, what can you trust, all of that stuff. I think that's going to be a really great use case for knowledge graphs and for Web3. Things like education. You know, education, I think, is a really interesting use case where things like universities, I think people have lost a lot of faith in universities, and we want to come up with new ways to, you know, create new, types of universities or educational systems, you know, courses, change how people organize and curate curriculums, and as communities decide, hey, like, what counts as a good education, like what kind of certifications do we want to have, stuff like that. So giving tools for people to form into groups, to organize knowledge that's useful to them. I think things like education is a really interesting area. There's just many, many use cases for all of this stuff. But whatever it is that's interesting to you, right, I think as a top level, like North metric goal for the graph, right, having more useful knowledge and information better organized should really be one of those North Star metrics that signify the health and the utility of the graph network. A second one is enabling interoperable consumer apps. So on top of this global graph of knowledge and information, we want to enable lots of different consumer applications. Developers should be able to build these apps, and they should be interoperable. And so, you know, we published GRC20. One of the next things that we're working on and that we're going to be releasing in the relatively near future is a framework for developers to build these consumer apps on top of the graph. And I think that's going to be really exciting for changing the types of applications people can build. And I think it's really going to redefine the Web3 space in a major way. And so you have kind of, you know, enabling these third-party applications, but then you have, you know, and this is kind of related to the news thing, but I'll leave you guys with this for now, which is if you want to have a global decentralized knowledge graph, right, public knowledge and information, you know, who determines what is true, and what kind of systems can we build that people can trust, you know, and this really is at the root of why Web3, why decentralization, all of this stuff is essentially, you know, lack of faith in the institutions and needing better internet native systems that we can build society around. And really everything is information, and I would claim, you know, everything is knowledge. Knowledge is a higher, better form of information. And so I published this blog post right before the break. If you haven't read it, please read this. It's called Governing Public Knowledge. Because when I start to talk about this stuff, I've noticed that, you know, a lot of people there's just so many questions. And it's hard to dive into something when you have so many questions about, hey, is this thing even feasible? Is it desirable? This idea of building a global decentralized knowledge graph. So I really address all of this head on here. And I start with a set of claims about knowledge, right? That there is such a thing as objective truth, right? That no person or organization can claim to know absolutely what the truth is. Knowledge is not evenly distributed. Some people have more than others. Acquiring knowledge is a challenging process that requires determination, curiosity, humility, intelligence, and hard work. So you start with these claims, and then you understand the design goals, and then we kind of build this up from personal spaces, right? The concept of personal spaces, it's open, anyone can create one of these, to public spaces. Public spaces should have public governance, what that means, how these spaces can be related to each other, how we structure knowledge and pluralism, curation. So these are really core concepts. Please read this post, and hopefully at the end of this you'll have a good idea for this. Now addresses the second missing piece here, right, which is the governance. And so all of these pieces are going to work together, and what we'll be able to do is build a global decentralized knowledge graph that anyone can use, can build custom applications on top of, that's verifiable, that's open, and that's composable, and that is Web3. And this is the year we're ready to roll this stuff out, and really excited to take this to the next step. So I'm going to pass it over to Christophe, and then we'll have some Q&A.
Thank you, Yaniv. All right, so hello everybody. My name is Christophe. I also go by Stouffer on Discord. And I've been working on the 𝗨𝗀𝗳𝘀 project since for about 6 months now, everything put together. So, and I'm mainly working on the indexer that, well, presumably you guys will be using to index data from the knowledge graph and then serve it to consumer apps. So without further ado, let me share my screen and we'll dive into the technicals of how 𝗨𝗀𝗳𝘀 is currently implemented. All right, can everybody see this?
Yeah, just have to click the watch stream, and there it is.
Okay. So this is a little diagram I put together before this call just to explain how 𝗨𝗀𝗳𝘀 currently works and where the indexer fits into the whole picture. So as Yaniv mentioned, knowledge is divided into specific spaces. Spaces can be personal or public, in which case there's a governance process to decide what knowledge is submitted to the space. I won't go into how governance works right now, but the thing to note is that all edits that are made to a space, whether that be creating a triple, editing a triple, deleting a triple, creating relations, etc., all of those edits are uploaded to IPFS, and then those edits are submitted for approval on chain with the IPFS hash of the edit. And once the edits have been approved, and whatever the edits contain become canonical knowledge for the space, then it is the responsibility of the indexer to fetch those edits from IPFS and then apply them to their own representation of the knowledge graph. So as you can see from this pretty bare-bone diagram here, there are 3 major parts to the indexer stack. We have a sink, which uses substreams to read on-chain events related to different spaces. And that sink is also responsible from fetching data from IPFS. Then the sink will apply the edits to the entities for that space that are stored in Neo4j. And then the second big component is the GraphQL API server, which exposes the data from Neo4j to consumer apps. So relatively standard sort of setup here. The code base, I will share that link in the chat right now if you guys want to play around with it and look at the code base. It's currently under the Playgrounds organization, but we'll presumably move that to the Graph protocol in the next few weeks. You'll find in that repo that there is a Docker Compose file, which you can use to easily spin up the 3 components I just talked about. You will have to create to use a substance provider. We've been using one hosted by Pinax. Thank you very much, Pinax, for that. But yeah, once you have that, you can run the whole stack locally, and you can play around with both the Neo4j instance and the GraphQL API that will expose that Neo4j data. And during Q&A, I can talk more about how the code is actually organized here and the nitty-gritty, but I would like to go over the database and the API first. So for those who are not familiar with Neo4j, it is a NoSQL schemaless database, which is purpose-built for highly linked data, essentially. So what that means is that relations are first-class citizens in Neo4j. And I'll show you an example of a query in a few seconds. But there's no schema. All entities in the database are basically just JSON documents. And the way you query them is using pattern matching. So for instance, if you have a node in your database that has a certain label, like say fruit, right? You can write such a query, and then you will get all instances of entities that have the fruit label. Likewise, you can also pattern match on individual properties. Like for instance, if some nodes have a name attribute, you can query all nodes that have name potato, right? Let me know if I should, I'll increase the size of my screen a little bit. Right now, this is the _𝗨𝗀𝗀𝗳𝘂 data, so there's actually no such node. But just to showcase what I meant by Neo4j having relations as first-class citizens, is that instead of having to do joins to traverse, relationships between entities, you actually pattern match on the relations themselves, right? So, for instance, if we wanted to get all the friends for a given person, we could first match on the person of interest, say, Eve, and then indicate that we want to fetch all nodes that have the friend relation coming from the Yaniv node to some other node, right? And maybe we make sure that these are actually people by indicating the label here. And then you would return P and M. It's not going to give me anything because there's no such data in the database right now, but this is how you can actually traverse relationships, and you can have as many of them as you want, right? You can then have, in other relationships here, like birthplace, right? And this is like some city, et cetera, et cetera. Now, to show you how we're actually representing _𝗨𝗀𝗀𝗳𝘂 data in Neo4j. I see there's a question here. Yeah, so this is where I'm getting at right now. So in _𝗨𝗀𝗀𝗳𝘂, everything is identified by some unique ID, which is not really made to be human readable. So for instance, an example of a _𝗨𝗀𝗀𝗳𝘂 entity would be, or a _𝗨𝗀𝗀𝗳𝘂 ID would be this, right? So this here is actually the GRC20 entity for the name attribute, right? So notice here that using the Neo4j Explorer, which sits with the Docker image, you can explore the fields of each node, and everything in GRC20 uses those IDs as identifiers. So this GRC ID here is actually the name attribute of the entity, which is name, right? And this is here the type of the attribute, which is text. So yeah, this initially we wanted to have Neo4j be the main interface for querying GRC20 data, but since you have to use those IDs everywhere, it's not ideal for humans to work with, which is why we ended up building a GraphQL API on top.
Right,
But
and
very quickly,
also this is just purely kind of a tooling thing, right? It would be a pretty easy, fork of this, graphical user interface, because basically we standardize with entities that they have like a name field, right? Name is an implicit property that every entity has. And so wherever we see one of these IDs, the tooling could just fetch the name
Yeah.
and then see the human readable name. So it's really just a tooling thing.
that's right. In theory, it should be possible.
Just allocations.
Sorry?
Yeah.
Cool.
Oh,
Yeah.
it's not. It's a SQL server, not MySQL. It's
Yeah, I think that addresses that question. Did you want to show the GraphQL API?
Yeah, I'll quickly just showcase this query here, which kind of is a bit more interesting to look at. What is happening here is that we are matching on nodes relations, which are also modeled as nodes in Neo4j, and then other nodes, where this Neo4j edge is actually the from entity attribute of the relation. This other Neo4j edge here is the to entity attribute of the relation. So this kind of reads as you have a relation R where the from entity is N and the to entity is M. And then we return N, R, and M. And you can see here that in blue is all the relation nodes, and then in gray are all the N and M nodes, which represent entities.
Yeah. So this is all very much still in progress, this knowledge graph data service. So, we wanted to give everyone kind of an overview of GRC20 and just kind of show you as things are developing. This as is not like ready for consumption yet, but you're getting an early preview while we're in development.
Exactly. And most likely you'll be using the GraphQL API built on top of Neo4j to consume data. This is similar to a query I showed before, where we're fetching the name entity, which is of type attribute. It has attribute name of type text, and it has relations to two other entities, one being the attribute entity, and then the other being the text entity. And how you can interpret this here is that the name attribute has a relation called types, the attribute type. So it says that name is an attribute, and it has a relation type of type value type towards the text entity, which says that name is an attribute of value type text.
Yeah, I think this is a good overview for this stage. So what you see here, is it's a very graphy kind of API. And then what we're going to be building on top is an SDK that looks much more typed for each application. So, if I'm building, an education app, right, I might want to define the schema for my application, and I should be able to define that however I want. And then I have an API that looks exactly the way that my application wants. right? This isn't going to be how I consume the data, right, for my app, right? If I'm defining courses and lessons and tutorials and this kind of stuff, that's how I'll interact with it. I'll also have really great typing, right? So if I'm building like in TypeScript, right, I'll have autocomplete and all of this kind of stuff. So it's going to feel very natural, very intuitive, and like a great developer experience for developers. But this is kind of the API under the hood that kind of makes that possible in a composable way. Christoph, is that maybe a good stopping point for this demo?
If give me a few more minutes, I can
Sure.
talk a bit about what's coming soon, what's left to do.
Yeah.
So yeah, in terms of the work remaining to bring this to production, we still have to implement a few changes in the protobuf models. Lately, we've added the ability to have the batch edit, something we call batch up. We'll have to update the backend for that. We also want to have much better observability, right? So I know as indexers, you guys love to connect everything to Prometheus and have a bunch of metrics and logs. That's still left to do. And then in terms of AI capabilities that Yaniv talked about, you all might be familiar with the concept of ragging, and more specifically, graph rag. Well, luckily for us, Neo4j has semantic search via embeddings as a first-class citizen. So the idea of generating embeddings for all nodes in the knowledge graph is definitely on the table. And yeah, we're pretty excited about this, and it's going to enable some pretty crazy AI apps.
Yeah,
Ellie,
it's really huge. It turns out that, LLMs are really great interfaces, but if you want to get accurate answers, the only real way to get accurate answers is to have the LLM, hit some kind of source of truth, right? That it just returns the answer to you from. And so graphs are the best way of representing complex relationships and complex, states of things. And it's a perfect complement for LLMs. You ask it a question, it figures out what the right query is from the graph. It can get a bunch of relevant information, and then it can synthesize an accurate response for you. So this really becomes just foundational thing that enables AI in a way that is grounded in truth, but in a way that's decentralized, right? So it's not one company that's deciding what's the truth, right? It's a decentralized graph that then the AI can use.
Exactly. And maybe if you just give me 30 seconds more, and some unsolved questions and problems we're still tackling is one, how do we shard the system so that indexers don't have to index all spaces? They can selectively index different spaces. And then there's also the question of, do we want to separate governance into a separate data service or not? These are questions we're currently exploring. All right, I yield back the floor.
Awesome. Thank you so much. So I think last thing, and I want to make sure we have some room for questions. I know we're 2 minutes till, but as far as indexers go, so we're working on getting this knowledge graph data service ready. We still have work we need to do to get this on the network. It's stuff that I think we need some core devs to help with ideally. And so we want to get this into your hands. One of the things that is going to make this different, one is at least this version uses Neo4j. So it would be interesting, if any indexers want to play around with Neo4j and, help us with some ops stuff there. It could be interesting to start looking into. And as far as how it changes indexing, we want to move to a model where indexers can choose which spaces they want to index. And then essentially, right, you're co-locating, you're choosing really what subset of the global graph you want to index. And I just think that's going to be super cool. Right. So if you want to index everything that's related to your city or your country, maybe you do that across every industry, across whatever, right? That's how you want to select your portion of the graph. And then you'll be more efficient in answering queries that are maybe geographically based, right? Or maybe you care about a specific industry. And, even from a global context, anything that deals with that industry you want to index, or, how, different patterns of what's useful across different industries or whatever. So, there's going to be thousands and maybe eventually millions of different spaces, but all of the knowledge is interrelated. And so it makes it much more interesting to choose which parts you want to index, to co-locate that, and to make the querying that stuff more efficient. So just to look at how indexing this global graph of knowledge and information is going to be evolving. But the next 2 months is going to be massive for rolling this stuff out. Leading up to the Web3 app framework, getting third-party devs building apps on this stuff, and hopefully having all of you running the infrastructure. All right. Do you have any time for questions?
Yes, if everyone is cool to spill over a little bit, then yeah, sure. We have a ton of questions actually. So what I've gone and done is put a question mark under each question so we can scroll all the way to the top and start with State Machine's question. And he asks, how does this compare to IPLD?
Yeah, interesting question. 10 more. So IPLD is linked data, but it's really meant for more like immutable linked data. And that's kind of an interesting thing, right? IPFS and everything, it's really for kind of immutable stuff. So if you, the content addressing thing only works so much, but the truth is the state of things is always changing, right? So let's say I have something like the city of San Francisco, and I want to know what is the population of the city of San Francisco, or I want to know, okay, what events are happening in San Francisco today, right? Somebody could have just added an event a minute ago. What's the content address for that, right? And the link to the right. So the model it doesn't really work for dynamic applications. I think what the query is more, okay, I have the ID for the city of San Francisco. I want to know the events, right? So and this is the information that I want. And so with knowledge graphs, you kind of have entities. The relations are the IDs, right, of the other entities, as opposed to being these content address links.
Amazing. Hopefully that answers your question, State Machine. And then the one below. Oh, sorry, State Machine. You want to comment, or I don't know if I heard you there. Just interrupt me if you are. And then Chris has another question here saying, what is the difference between information and knowledge?
Yes. So knowledge is when you link and label information to achieve a higher level of understanding, right? So you could think of subgraphs as basically being like information, right? Essentially, there's a structure, right, defined by the schema, and then you're taking like this raw blockchain data, and then you're like indexing, right? You're giving it structure. And so that's the transformation into information. But you can have all of this information in your database, and you're missing context, right? So you have these users, you have these transactions. Was one of these transactions, happening as a result of a hack? Is one of these users, a power user of this protocol, a first-time user, right? So there's all of this stuff. So you could think of those as like labels almost, right? Of like, right, enriching things, and then the interconnections between things. And think about how your own mind works, right? When you're learning things, right? What is knowledge in your own head, right? You're making connections between things. Oh, this is kind of like that. Oh, wait, this contradicts this other thing that I heard, right? So it's all of those connections that you make between things. So you could imagine, for example, say you had a video of like a talk that was given at a conference, and you could transcribe that. So already linking the transcription to the video, right, that's a connection. And then you have this transcription. All of these are individual sentences that are made, right? And so those are individual things that you can connect. And then each one you could say, hey, is this thing accurate or is it not? What actually happened here? Oh, in this video, somebody announced a new product, right? So that's all information that is interconnected. And if you can connect all of these things together to form a higher level of understanding, that's really knowledge.
Fantastic. And then the next question is, why are graph structures better suited for finding LLM context versus vector stores or relational stores, given all SQL in training data?
Yeah, it's a good question. So definitely you want vector, like embeddings as well. And so it's for different kind of parts of the problem. So like Neo4j supports embeddings, and you need that for LLMs. But the reason is that you really want a way to precisely get the most relevant knowledge, and you want that knowledge to kind of be up to date. And so the just graph queries are just the best way to do that, right? The problem with the relational model is that, again, it implies that you know the structure of things up front. And the reality is that as you're building applications, even within a single application, the schemas are often evolving, right? You're realizing, oh, we need another field to support this new use case, or actually this thing is related to that thing, we need to add that. That's within a single application. But imagine that you have 1,000 applications, right, that are touching the same, courses and lessons, because there's all these different ways that you want to build customized educational apps or whatever it is. The structure of things are constantly evolving. So relational database is never going to account for the dynamism of things constantly evolving. So that's why graphs are powerful.
Amazing. Next question is, how does public and private, e.g. gated institutional knowledge, interoperate on the knowledge graph?
Yeah, so this is something that we're building as part of the framework, and I'll share some details about that with you guys first. So I'm really excited about this. I think it's going to be game changing. So for the first time, we are looking at how to support private, shared, and public knowledge and information, because I think if you're building applications, it's actually very rare that an application only deals with public information, right? Maybe in DeFi, we'd say that a lot of the stuff so far has been public, it's all on chain. But for generalized applications, maybe there's like a publishing step, right? There's a point in which you make something public. Okay, here's a video, here's a post, here's a something. But a lot of times they're working privately, right, or with a team, right, or with family. So in order to enable Web3, you actually need to be able to build applications that cross those boundaries. You're empowering the user, they're performing some actions, maybe it's with private knowledge and information, or maybe they're sharing it with their team, and then they're selectively publishing some of that. So the knowledge graph structure can encompass all of that, right? Because spaces can reference in knowledge and entities across different spaces. Right? It's just a question of like, is the space public or is it private? And if it's private, then you can encrypt it and you can make it truly private. You can keep it just on the user's local device. So this is all stuff when people talk about Web3, right? They talk about this kind of stuff. I don't think this vision has been realized yet, and I think we're going to be the ones that make it happen.
Fantastic, very exciting stuff. So the next question is, how does the knowledge graph prevent GIUD collisions? Yeah, that's the next one. How does the knowledge graph prevent GUID collisions? First come, first serve, plus subsequent permission enforcement by KG node indexer, question mark?
Yeah, so this was one that in the early days it took me a while to wrap my head around. And basically what this comes down to is just governance. So you can have personal and private spaces that basically like are untrusted, and you can publish any kind of garbage that you want into your own personal space. So that can include like terrible knowledge and information. It can include obscene things. It can include like ID clashes, all that kind of stuff. Now, public spaces don't have to include you as part of their public spaces. So if you have ID clashes because you have a malicious, UI or a user or something like that, essentially it's up to the governance of the public spaces to filter that stuff out and to enforce, quality. So that's how it's done. Basically, any client that is not acting maliciously should be able to avoid collisions. And then it's really just up to public governance to include spaces that are behaving properly.
Amazing. And next question is, how do you see the discovery and adoption process for ATTRS? I'm not sure how you say that. I think that's how you say it. Attributes. Okay, great. Thank you. What are new barriers for an adopter to adopt existing attributes, e.g. right perms via governance? how to prevent attribute fragmentation by each new user, e.g., my birthday attribute versus your birthday attribute.
That's right. Yeah. So great question. And this is where really interesting stuff, comes up when you're thinking about like how we're going to build these Web3 apps. That's for sure kind of core to this. And part of what we want to do, and that knowledge graphs are uniquely suited to do, like ours, is to really balance full freedom and customization with reuse and composability. Right. And in some ways, you could say those things are kind of in tension, right? Because if everybody's like, hey, I'm just going to do my own thing, then you're not actually going to get much reuse and composability. And so what you want to do is you want to make it easy to reuse things, and you want to make it easy to share things. But then if there's like a valid reason for people to be like, no, well, what I'm doing is different, to give them the freedom to customize and to just change the things that they want to be different, so that they're still getting maximum composability and reusability, but they can just tweak things the way they want. So a lot of that just comes down to the developer tooling, right? So you could imagine that, okay, let's say that I'm going to build a news app. And so there's already a news story out there. There's already these like base types. So you want to make discovery of those types easy. You want to make discovery of, okay, here are public spaces, here are things other people are building. So your first step will be like, okay, let me pick the existing things that are closest to what I want, and I'll just reuse those. But one thing that's really awesome about the knowledge graph type system that's different from your traditional type systems is the way that the attributes are decoupled from the types. And so I can use an existing type and I can just add my own attributes to it. And so it's not like it's all or nothing, right? So maybe I want to use the news story type, and there's 10 attributes on there that are basically like I want to represent the same exact information. So I'll just use those attributes, right, on my version. But then maybe I want to just add one or two attributes that weren't defined on that type. Well, that's very easy for me to do. I just add those one or two attributes or my version of an attribute. So I can customize what I want, but with proper tooling, it should be very easy to maximize the reuse, if that makes sense.
Fantastic. Matthew says LMS stands for Learning Management System, and I believe that's already been answered. And then you got another compliment from Chris saying, really love the graphics in the GeoPost, which is great. And then we have a question from State Machine, which is quite interesting because I don't think this is really solved in Web 2, let alone Web 3, but the question is, who is responsible for content moderation? Can we build a Web 3 Wikipedia with it?
Yeah. So all great questions. Yeah, learning management system, content management system, all of this stuff, we can kind of do on this. For moderation, it kind of comes down to the spaces. I would read the knowledge, the governing public knowledge post, because it addresses this question. I call the concept limits, right? And maybe there are some limits that should be enforced across the global graph. That's an interesting question. But ultimately, each space can define its own values and principles. And I think from a philosophical level, right, this is something that we're kind of introducing a little bit, because it's hard to know with Web3 a little bit, what are we doing that are tools for individualism, and what are things that we're doing that are tools for, let's say, coordination, and you want a balance of both. And so, freedom of association, freedom of, you can create your own space and you can do whatever you want, and other people can't tell you what to do. I think that's important, and we want to support that. Obviously, different jurisdictions have laws, and we can't necessarily help you, coordinate in a way, if you're breaking the law in your country, law enforcement might show up at your door. I don't know, we're not going to stop that. But ultimately, these are interesting questions, and I think what we want to do is we want to empower communities to, part of coordination is being able to define your own values, your own beliefs, your own, principles and policies. And then within your space, then you should be able to enforce those. And that way, people who have same beliefs can work together. And so, yeah, I think, we're providing tools for communities to do that. And you could build a Wikipedia on this. Now, sometimes people, in a sense, people look at it and they think that it's kind of Wikipedia-like. I think, it's much more than Wikipedia, right? I think Wikipedia is a starting point, but Wikipedia is for mostly objective information and mostly static. And most interesting information, a lot of it is subjective and it's dynamic, right? So if you think of, X, most X posts aren't making it onto Wikipedia, but they should all be part of the knowledge graph, right? Anytime someone publishes something, that should be part of the knowledge graph. Reddit, same thing. The comments and the conversations that are happening, that should be part of the knowledge graph. Markets and products and services and basically every application should be part of the knowledge graph. So it's much bigger than Wikipedia, but you could use that as a starting point.
Where does truth fit into that, though, Jan-Yves? Because what you've just described is sort of like the formalization or the crystallization of, infinite realities, which is where we are today, right? Where there's no such thing as truth, almost.
Yeah.
So where does truth fit into that?
Yeah, so this is a very deep topic, and it's really the subject of this post. So please, everybody, make sure that you read this governing public knowledge post. It lays the foundation for really understanding that question, and I think it's the biggest question of our time. And I think some people are almost afraid to tackle it because it's such a big question, but I actually think this is the single largest problem that humanity has today. It's the biggest problem of our time. And if the graph solves this problem, then we, by definition, if you solve the biggest problem of the time, I think you build the most valuable thing. And I really think the graph can be the most valuable thing. It's why I've dedicated my life to it. So the way that I answer that question, right, you need to kind of have the right kind of foundation. So this post goes into it. It starts with how you structure knowledge and information, right? So you can't just represent facts and then everyone's like, yes, that's a fact, no, that's a fact, and then you're screaming past each other. And so you have to structure the information in a way that's correct, even if there's disagreement. So if you have things like claims, right, someone can make a claim, that doesn't mean that it's true. And then you structure things like supporting arguments and opposing arguments. You can just observe who supports which claims, and you can kind of structure the stuff. And essentially what you do is, you have these spaces, and each space should be able to kind of get to consensus on its own. Now, again, if you force everyone to agree on everything, you wouldn't even get a single space to consensus. But if you structure things in a flexible enough way, then you can get a group of people with shared beliefs to kind of agree on a state of the world and to be like, okay, I agree with how we're kind of doing this. And then the question becomes, can you organize these spaces into larger and larger, configurations that represent essentially global consensus. Now, global consensus does not mean truth, right? The consensus is often wrong, right? And so, but what you want is to give groups the ability to represent knowledge to the best of their ability. And then you want to interconnect that into larger and larger communities. And you want to have a system that converges toward truth. And so there's a lot that kind of goes into that. This post kind of goes into it quite a bit. There's really a very strong, I think, philosophical underpinning for how to think about this. And I'll just leave this, and then maybe that's a good place to end with. There have been systems that have done this before, and they've done a really great job. So we actually have an existence proof for civilization functioning. I think in the industrial age, we had this issue after the printing press, where suddenly anybody could publish anything, and it created so much noise, and nobody knew what was true, and and then you had institutions that kind of allowed people to trust things a little bit more. You had these news and press institutions that gained reputation over time, and with journalistic integrity and the way that they did that, people started to believe the press. You had universities governing knowledge, and with peer review and all of these systems, it was decentralized, but it really allowed us to advance science and knowledge. Governments did a really great job with their processes at the time for coming up with laws and studying things, and so we know that this kind of thing is possible. And then really the only question is, how do we do this at scale in the internet age? right? Where anyone can publish anything. The orders of magnitude of noise is much more, but we actually can build the same sort of systems. And so essentially that's what this is, right? It's a generalized system where if you build a system, it doesn't mean that the system is always correct, but it means that, if the design of the system is correct, then that it's like by definition, it's the best that you can do, and people can trust the system, and you can trust that it's self-healing and it's improving over time. And I essentially think that's what we can build here.
Amazing. Just want to check in terms of time. How are we for time? Would you like to answer?
I've got to hop off, so hopefully that was a good
Wrap?
starting point to this, and I'm very happy to come back on whenever we want to dive deeper. I'm really excited to start working with more people to get this stuff out into the world.
Fantastic. Well, let's take that opportunity to wrap then. Massive thank you to you both, Chris and Yaniv, for all of your wisdom that you shared with us. All the links are in the chat, so guys, feel free to check that out. Maybe final words, if you will, I guess, before we wrap. Would you like to say a couple words?
If that's for me, I think the final words is, we've been working on this for a very long time. It is now ready. We're going to be rolling it out over, in a few different stages. And what I'd love to see is collaboration. Collaboration across participants, across core devs. I think in some ways, maybe this looks a little bit different than what we've been doing before. But I think the opportunity is just so much greater. We don't want to think of ourselves as purely an indexing and query protocol, because, there's hundreds of services out there, for just like querying blockchain data. And if that's all we are, we're one of 100, we're one of 1,000. We can be slightly better, but we're talking like marginal improvements. The indexing is a core part of what we're talking about here, right? The same way that Google does so much more than indexing, but they're viewed as indexing. It's an important part of the stack. And the fact that we do indexing better than anyone else is going to be a huge competitive advantage. But we don't want to be a commodity. And so the way that we move beyond just being a commodity is we actually tackle the biggest problems of our time. And we do things that are really important, that's going to change society, that's going to make the world a better place using these tools. And that was the idea, for the graph from the beginning. So everything is knowledge and information. If we can build the global graph of all of the world's public knowledge and information organized and served in a decentralized way, for me, that is the graph. And that is also the most valuable thing that can exist, I believe. And so how do we get there? Let's just focus on these. There's really 3 goals, but we'll start with these 2 goals, which is more useful knowledge and information better organized, and enabling interoperable consumer apps. And if we just focus on those North Stars in the short term, the other one is related to the incentives, and Rem has already talked about improvements to the incentives. So, leave that conversation to that thread. But if we enable those things in the short term, then we need a bit of a 0 to 1 moment to really get this Web3 thing kickstarted. But that's basically what we're going to be starting at the beginning of the year. Would love to have more people working together. Like, let's collaborate. Let's do such a great job with this that we really make Web3 incredible. We get it out into the world. We grow extremely rapidly, and we make the world the vibrant, decentralized place that we want it to be.
Fantastic. Well, I do appreciate the inspiring words that you've left us with. Yeah, massive round of applause. There you go. And then we have the future that we all want to move towards in the chat. We like that gift. Thank you. Thank you, everyone, and really do appreciate you spending some extra time with us to go over this stuff. I couldn't think of a better person to have on for the first IOH of 2025 than Yaniv. Very inspiring individual. And yeah, we're going to be back every week, 5 p.m. UTC, and we look forward to seeing you all next week. Take care and have a wonderful rest of your week, everyone. Bye-bye.